Hello everyone, this is Trisha Naik from TE Electronics, and today I am designing a PWM or pulse width modulation circuit using timer IC 555. The 555 IC gets its name because of the three 5 kilo ohm resistors connected internally. The first pin, it is an 8 pin IC, so let us see the pins one by one. The first pin is ground. The second pin is trigger. It is the negative input to the first comparator. When you give a negative input or a negative pulse to this pin, the internal flip-flop is set, and when the voltage drops below 1/3 VCC, the output goes from low to high. Pin 3 is output. Pin 4 is reset. It is an active low input. Pin 5 is control voltage. You can use this pin to override the 2/3 VCC level of the voltage divider. When it is not used, it is connected to ground via a capacitor. Pin 6 is threshold. It is the positive input or the non-inverting input to the second comparator. It is used to reset the internal flip-flop when the voltage which is applied exceeds 2/3 VCC. It causes the output to go from high to low. Pin 7 is discharge. This is connected to the collector terminal of the internal transistor. It is used to discharge the timing capacitor when the output goes low. Pin 8 is the VCC or the supply pin of the IC. The 555 IC has the following modes. You can use the 555 IC in these 4 modes. The first one is the astable mode, which doesn't have any stable states. The second one is a monostable mode, which has one stable state only. The third is a bistable mode, which has in which both states are stable, and the Schmitt trigger or the inverter mode. The PWM circuit is based on the monostable mode of the 555 timer. That is, it has one stable state only. So for a monostable multivibrator, if you apply a negative pulse to the trigger input or pin number 2, the internal comparator, that is the first comparator, the input is detected at that pin, and the internal flip-flop is set. So the output changes from low state to high state, and the capacitor starts charging through its resistor until the voltage reaches 2/3 VCC. When the voltage reaches 2/3 VCC, the comparator output becomes high, the flip-flop is reset, the transistor then turns on, and the capacitor discharges, and the output state goes from high to low. Therefore, as you can see that the monostable multivibrator has only one stable state. So pulse width modulation. In pulse width modulation, it is also called pulse duration modulation. Basically what happens in pulse width modulation is that the width of the output pulses changes in accordance with the amplitude or the magnitude of the modulating signal. So this will be better understood through the simulation. So this is the circuit for a PWM using the 555 timer IC. So the reset, I've given a high or a VCC. Out you get V out from this pin. I've given a trigger input to the trig pin. Ground is connected to ground. The modulating signal is given as a sine wave, and VC or control voltage, where I have my resistor and the capacitor. These are the values for the various parameters which I have given. Also, the sine wave I have given is 1.5 volt. It has an amplitude of 1.5 volt and a frequency of 40 Hz, which is quite low. So let us run this. So now I am going to add 2 more plot planes to see the various outputs. So now So if I go to the first one and I get the output for the modulating signal, this is my modulating signal, and I'm also going to get the output for the capacitor. This is the capacitor or VC. For the second plane, I'm going to get the trigger. So this is my trigger which I am giving to the IC, and finally my output which I am going to get from here. So let us get output 2. Yeah. So as I can see, let's maximize this. As I can see that the green one is my modulating signal which I have given. It begins, its positive peak is at 4.5 volt, its negative peak is at about 1.5 volt. These spikes are my capacitor or VC voltages. This is the trigger which I have applied, as you can see here, to this pin, and this is my output. So if you notice the modulating signal and the output signal, I can notice that when the modulating signal reaches its positive peak, that is when the width of my output pulses is the most. Similarly, when my modulating signal reaches its negative peak, that is when the width of the output pulses is the least. So as it goes from the positive peak to the negative peak, the width of my output pulses progressively decreases. Similarly, when it goes from the negative peak to the positive peak of the modulating signal, my width of my output pulses progressively increases. So this is how a PWM works. So you can see my output here. So to conclude, the 555 IC can also be used for pulse position modulation, which is quite similar to pulse width modulation, the only difference being that the frequency is not constant in pulse position, whereas for a pulse width modulation circuit, the frequency which we give is fixed, which we gave in our case as 40 Hertz. Other applications of the 555 IC are listed here, for example DC to DC converters, clock signals, debound switches, waveform generators, etc. So this was all for pulse width modulation using the 555 timer IC. Thank you.